Our midterm exam will be on Monday, October 30th. I think it is 3 weeks uh, from today, right? Um, the exam is an in-class exam, so everyone should come here on Manhattan campus, uh, the MT 425. The exam will be given to you 2 hours. The exam actually will be designed to take maybe less than an hour, maybe 45 minutes long exam, but I will give you 2 hours maximum. It'll be a closed book, a closed computer, and closed your cell phone. No electronic devices are allowed, permitted. But one-page cheat sheet is possible. So you can bring one-page cheat sheet. You can make it. If you do not like, you don't need to make. In other words, you don't need to memorize all details. I'm not going to ask you to all details, something awkward questions. Everything's reasonably understood from the lecture that I gave to you. All right, so we can talk more about this Monday in-class exam, which is the last day of October, second last day. I am expecting some of you may say, hey, I cannot come. No, you should come because it is designed from the beginning. If you can give me proof record that you live 100 miles away from any campuses of Mercy University, then you have to find your own test center. You can visit the nearest test center from you. I'm not sure it is closer to your home. Sometimes your test center may be 200 miles away from your home. Then you need to come to Mercy University. So this is preferably here, Monday 11:20 to 1:20 p.m. If anyone unlikely impossible to do this, then I can give you exam earlier than this on campus here, maybe Wednesday before this 30th. Then what is the Wednesday before October 30th? Maybe 27th, probably around that, right? If you can come to the Manhattan campus in the evening, then I can give you also. You can do that. That is also possible, okay? But you have to let me know earlier. That way we can arrange it. Otherwise, that is your responsibility. We can manage some alternatives, but online exam is not alternatives. It should be under proctor. You need to find the proctor on your own. Then I can send this exam to the proctor that you hired. That is alternative. Or you can come to the class here Monday. This time, hopefully everybody to come here. If you cannot, then another alternative here on Wednesday, week before this, evening. I can manage that also. All right. So today, the lecture is here. Today we'll look at data types. Okay, data types. A variable is a placeholder of a value. For example, name equals Sam Smith. Then Sam Smith is a given data string that can be assigned to name. Name is a variable. So when you hold this variable, then you can get this value because variable is the placeholder of this value. The variable can hold any thing in another type, like floating points. That also possible. What if you hold multiple values? Those multiple values, then you have to declare multiple times of variables. Each variable should have different labels, right? If you have 100 values to manipulate, then those 100 values needs to be labeled. Therefore, on your coding, you can reach each of those values by holding that labels. Then logically, you have to define 100 times of different variables, although it is not efficient at all, right? So give me a second. So this is an example. So if I give you some motivation, let's say you have multiple people. So for a number of objects, if you want to represent those objects, then we can simply think of a set of objects. Then how can you represent this in Python? That is the issue. Another thing, how can you represent an object, one object? How can you describe this object? All right? So those things are the motivation and how we can handle that in Python. That is the issue for today. All right? So let's first start with a list. List is a data type that can hold multiple values. But ideally, list is a variable that can hold the values of the same type objects. So for example, if you have a name, let's say Adam Smith, Peter, Olive, Chris, and those as many as you could have, and you want to access these values on your code, then the way that we learned so far is you need to say name 1 equals Adam, and then you need to say name 2 equals Smith, and then name 3 equals Peter, and so on and so forth. What if we have millions of those? It's almost impossible, right? Is there another way that we can do the same representation, or even more efficient representation? Is it possible? Yes, it is possible. So that you can declare name. Name is a variable, and this variable can hold everything together like a set. All right. So list is in the form of open square bracket and close square bracket. That is the form of the list. Okay. In this way, when I print name, then I can have those names. So when I have this, then I have, oh, Adam, Mr. Peter, Olive, Chris, as many values as I would like to represent in one can be held by one variable, which is called a list. And then this Python can understand if you declare it with a square bracket and end with the square bracket. Each values can be delimited by comma. Okay, one value, comma, another value, and another value. Then someone may ask, how can I access each of those? You can access, for example, the first element of name is remember this is the format. So I have dot format, and we have one the placeholder here. If curly braces is in the string format, curly braces in the string format, then that is nothing but a placeholder of value, and this value can be fed by format function. So in this format function, because we have only one placeholder, we need to say what is the first element of the list name here. Then that can be name and then square bracket 0 and close the square bracket. Similarly, you can make this. Let's say, what about the second ones? Then you can say second one can be replaced by the indexed by I would say the values could be multiple. Values of a list can be accessed by an index. So index is starting from 0 to whatever, n. Okay? I want to save this so that we can access this later. So 505 in class 427. I have homework 3 and B. Homework 3, I made the homework 3, but I didn't give it to you because I want to combine the work that we studied last week with the today's lecture together. So a little more volume of lecture will be given to you. But anyway, this is saved. If I execute it, then it comes with this. The first element of name is Adam. So Adam is in the first place. If you want to access the first place value from a list, then the index should be 0. because index counted from 0 to whatever value. If we have n objects, then from 0 to n minus 1. Second element can be accessed by number 1. Third value can be accessed by number 2, right? So third value can be accessed by, third element can be accessed by number 2. You can do this more and more. What about you do the last element? Last element can be accessed by you have to count 0, 1, 2, 3, 4, whatever. But should you count if you have millions of those? Is there another way that you could do? Yes, the last one could be -1. So you can count from the forward, in the forward direction, then you need to count from 0, 0, 1, 2, 3, 4. If you want to count from the back end, then you can count it by -1 and the what? -2, -3, -4. Okay, so this is similarly, you could do, this is the last element. What if we do second last of the element? Then you need to do -2. Okay, and then you can make this. So last element is Chris. So you have a Chris here. Second last element, that is Olive, right? We can add more here, for example, Dave. Then it would be different, right? The last element will be Dave, and second last element will be Chris. All right, so once you declare multiple variables in a list, then each variables can be accessed by an index. What about if you want to, let's say I would put here the value of a value in a list can be accessed by an index. What about range values can be accessed by indexes, but that's in a way that x colon x plus whatever I. So if I want to access, for example, access the second, the values second to fifth of a name can be accessed by, if it is from second, then index should be what? First can be accessed by 0. Second can be accessed by 1, right? So we put here 1. And I said there is a colon, using colon, right? So 1 colon, and then what is the fifth? Fifth will be accessed by 4. But when you describe the range then the second number should be the number over the index that you want to access. So it should be 5 here. What it does is that it will return the index 1, including index 1, to 5 second index, but exclusively. So fifth element is not included, but closer to that. Okay? So if you do this, what is the second one? The second one is the Smith, right? Third one, Peter. Fourth one, Olive. Fifth one, Chris. But the first, second, third, no. If I want to access the fifth, up to fifth, then I need to put here. Fifth one can be accessed by 4. Yeah, this is the first, second, third, fourth, fifth. Yeah, up to Chris, right? So this is right. Yeah, up to fifth. But as far as index wise, the first index is the index that we include. So index 1 means second one will be included. From these points, I need to include all the way to the index 5, which is sixth, but sixth is exclusively the second index. So 0, 1, 2, 3, 4, 5, but fifth one is exclusive. So up to Chris. That is exactly that we want to access from second to fifth element. Okay, first, second, third, fourth, and fifth. Up to Chris. If we want to access the fifth, then the second number should have that number, fifth number. But first number here, that should be one below this. Instead of 2, you need to have 1 here. Okay? So we can access that. We can do this from backward as well. You want to try that? Let's say the values second and third. From the second last to fifth last. Then what is that? Second last is, this is the last. The second last is a Chris. From Chris, second last, third last, fourth last. This is the fifth last. How can using negative indexes. Then you need to do, if it is a second last, then you need to do minus from negative 2 to negative 5, second last. This is a little tricky. So let's try with this and see what happens. This is not. Then we need to, I think, put from 5 to because this is the number issue. Right. So you need to start with minus 2 to minus 1. Right. Because the second one, that is exclusive, right? So negative 1 is the last, but we want to get the second last. So you need to, the second element in this range, the second number, that is a number of index exclusively. But it starts from negative 5. So this is negative 1, negative 2, negative 4, 3, negative 3, 4, 4, and negative 5. Smith is a negative 5. So that is what you want to do, right? So from Smith to Chris. Okay, so negative 5 to negative, Chris is actually negative 2, but if you put here negative 2, then that will be excluded. Therefore, you need to increase one more, so it'll be negative 1. This is a little tricky, but same idea. First element, there is inclusive, start from there. The way you count negative 5, you count from negative 1, negative 1, negative 2, negative 3. You count that way, but the second value, that is exclusive. Okay. All right, next one is how can you manipulate this? The list has multiple functions, or we call that method. Already defined. So we can use it. For example, that is method invocation. So-called method invocation. How can you do method invocation? So I want to look at together with you. If you go to help, and then if you say list, then there are lots of methods already defined. Okay, so let's move. Anything that starts with the double underscore, then that is something that is declared as an object. So this is a really method. So append can contain object to append. Clear, if you say clear, then remove all items from list. Clear is it's remove all item. Similar to clear, if you have, for example, so we'll see that a little later. Count, it gives you a number of occurrences of a value. If you want to see how many of element appears in that value, then you can do this. For example, print I want to get this from the terminal. Python help and then list, so that we can report this clearly. Oops, I don't want to it's not, because this is a Linux. If I do list, then page by page, oops, disappears. Okay, I'll leave this here, and then we can move back up somewhere here. We're trying to see count, how many, it returns a number of occurrences of values, right? So I want to execute this. Count is not defined. So what you need to do here, this count is not count with the list name. So you need to put here name dot count. Count, this method is defined within the list name. So we have to, the invocation should be done by the way it is invoked. Invocation is list dot method. List dot method. So name is the list. We put here dot and method count. When you call method, you have to follow whatever, however it is defined. So count here, we need to put values. So we put David there. How many the value David appears? So we hit enter. Then it says Dave appears 1 time in the list name. The list name is a variable. If we put here one more Dave, maybe somewhere here, Dave. Then it'll return. Unterminated with, because I need to put a string. Quote David, quote, comma. So here David appears 2 times. 2 times in the list name. That is a count, right? Now I want to practice append. If you want to increase this the name right now, if you type name is a list that can hold these names: Adam, Smith, Peter, David, Olive, Chris, David. I want to append. So more. Let's say append John. Then it goes into the last append. So name is the variable list, right? Dot, and then I need to call method name, which is append. That append method once append method wants an object, the similar objects, right? So we are now describing a list of names. So we need to put name, John, here. Okay. So if I hit enter, and then what is the name now? Type name, then John is appended to the end of this list name, right? That is append. Append, for example, multiple names, then you need to put multiple names in a list. Say Brown and Chris, Paul. In order to do that, then you need to have another method called here, another method called the extend. Extended will take iterable variable. As you said here, iterable object is one object that can be appended to the end of the list. Extend, you can take a iterable. One of iterable is another list. So you can put this all list, copy, and then extend. If that contains entire list, and you can execute it. So what is the name after that extend? Then you need to have, see here, Brown, Chris, Paul. You put there a list which is iterable, but as you extend, it includes everything. You unfold this, unpack, I would say unpack this list symbol and append. That is what extend can do. If you compare this from append, if you say name dot append, and inside if you put the same ones, then what happens? And if you say name, look at this. The above, this is the result of this extend. The value to extend is iterable, another list. Similarly, if you use append with the same value, which is iterable, then the result will be this. Look at this and this. I cannot. Oh, I cannot highlight separately. Can I highlight this and that? No. Right. So this I want to compare with. I will do it this way. I want to make the double pound sign, so it'll be executed up to this. Then I have name this, and when I comment this, instead of extend, if I do append, see what happens. And name. Then I'll have this. Here's what I do. A little better way. If I do here print name, I will do here print name. And then I will to make it clear, I want to copy this here, and I will do name 2 instead of name. I will do, doesn't matter, name. Okay, I'll disconnect from the above, making the separate ones. Here is, after you extend it, I want to assign this extended version to extended name, and then I want to print extended name. So I don't need to make this another once. And here I would do appended name. Appended name. I think in this way you can see. Oh, this is not. This is the name itself. Yeah, it doesn't really, it doesn't go to that way. Simply name. Anyway, it's not working that way. So one time this way, one time another time that way. That's what I want to do. Okay, if I do this, then if I do append, then this list can be, when I extend, then this list can be appended. Each individual of the values in the list can be appended. So I would say here extended version of that. So I can do this. So extended version of that. I want to comment this out, and I want to open this, and then I would say this is appended. Once. So if I do this, then that is appended. Now you can see it clearly. If it is extended, the same value, this, then this extended method collapse this the iterable into each individual values, and then append each individual to the list. So it end up having Brown is appended, Chris is appended, and Paul is appended when you use extend. On the other hand, if you use append, like this append, then all together is treated as an object, so it can be appended to the end of this, to the end of that. Okay? You see the difference now. So I want to, you can see the difference by having that. Okay. Another thing that I want to, the one that you can see many times is insert. Insert can take two parameters. First parameter is index, second parameter is an object. So far what you have here, all appended, then you so far have Adam, Smith, Peter, David, Olive, Chris, Dave, John, Brown, Chris, Paul. And then next one is a list as an object. This is an inner list. Brown, Chris, Paul, all together in a list that will be the last element. Okay, so say this is a name, right now name. So what is the last element? Then you need to put here -1. When you put -1, then there is a list as is, because I put here append. When I put append, then even if that is iterable, even if that is a list, that list can be treated as an object, so all together can be appended, and clearly it stays in a inner list. So outer list, point of view, we can access each element by index. Then this is the first element, this is the second element, third element. In a way, from the global view, this whole together will be the last element. So when I enter here name -1, then as last element is all together. The list itself is the last element because I appended the list as an object, right? So I would say the name is print is -1. That's what we looked at, right? The last element in the name, that is Brown, Chris, and Paul. What is the second last? If we put here again, second last element will be -2. Then that is a single element. The last element is a list. The second last element is simply Paul, right? If you look at this list, then the last one is a list, second last one is a Paul. Someone may want to see we'll look at the insert function. Insert function can have, for example, index and value, right? So that I want to insert name dot insert. I want in the list here. I want to insert after Adam. I want to insert a new value. Let's say Ethan. Okay, I want to put Ethan. Second element in the list name. Then, as you can see here, Ethan should be the second parameter, so that we can put here Ethan. First parameter should be index. What would be here, the first parameter? If I want to have, for example, Ethan here, between Adam and Smith, I want to put Ethan. This insert, if you see here, insert object before index. You put here before. This index should be the number, but this object goes into the index before the given index. Currently, what is the, if it goes before Smith, then Ethan should appear here, right? What is the Smith index? Smith index is number 1, right? So before number 1, it goes into. So you need to put here 1. Then it goes into. So if you type here name, then name will have Ethan goes before number 1. Number 1 means before it was entered. Before it was Smith is number 1. As you enter this number 1, then Ethan will be number 1 index. So this number 1 can be treated insert object before index, or you can say insert object, therefore that object can be accessed by that index. If you put here number 1, then Ethan can be indexed by number 1. That is an insert. Now my question. Add access access the last crease. If you see here, currently name is this. Name is a list that holds some of atomic value, but the last element, that is the list itself, which is called the iterable, the value crease appears 3 times, right? Actually, if you say here name dot count crease, then it gives you only 2. Why? Because this count only at the top level. Top level crease appears here, this crease appears there, but the last crease is within the iterable value, which is not atomic. Therefore, globally, this value is, when this value is counted, this is not counted internally, because there could be multiple other deeper and deeper level of the iterables. So it counts only at the top level. Therefore, it appears only 2. In this case, access the last crease, which is in the inner list. How about that? Then that is clear, right? So this list, how can you access this? But we know name -1, then it gives me this. But what this guy says is not this whole as an iterable, but I want to access this crease itself. Within that inner list, I want to access a specific element. How can you make it? This is the same idea that we do have. It can be accessed, print name -1. What is the name here? Name itself here. There is a list, right? If it is a list, then you can access it by having square bracket, index, and close square bracket. What about entire this? That is also a list. That is also a list. Therefore, if you put there open and close a bracket, and if you put index, oh, this should be -1. If you put index, crease appears second element from the beginning. Therefore, you put simply number 1, then it'll return that crease. This is a crease. Do you see that? Therefore, a little more critical. I want to put Nathan to end of last inner list. So what is the last inner list? Then we already know that is a name -1, right? That is the last inner list. So we have a Brown, Chris, and Paul. I want to append, I want to add to the end of the last inner list. After this Paul, I want to put Nathan. How should we do that? When you append to the last, then you need to use simply append, right? As you did here, append. Append to a list. If you have a list, then list dot append. That's what we used, right? Where did I say that? Yeah, I said the list dot method. List dot method. If it is a list, then after that we use the dot notation and followed by method. If I say I want to add Nathan to the end of the last inner list, then we need to find out what is the last inner list. That is nothing but name, open and close square bracket, -1. That is the last inner list. Then -1 is nothing but a list, so that we can append Nathan to this. So simply we do name, -1, and append, and then we can put here Nathan. After that, if you to print name, then clearly we can see. Now Nathan is in the last element, which is iterable. Right? Similarly, if you simply say add Jeff to the end of name, then you can simply say name append Jeff. That's what we had. So print name. Then now Jeff is the last element, which is simply an atomic value. Second last now will be at least iterable. You can remove a value, some value. The first value occurs in the list. So if you want to see, I want to remove Chris. Then you can simply do remove Chris. And then if you put name, the first Chris will disappear. This is name. Chris, where is the first Chris? First Chris is here, right? This Chris will disappear. So if you compare here, this Chris will disappear. If you come back here, then that Chris is not. This Chris was between Olive and David, but come down here, Olive and David, there is no Chris. Similarly, you can remove Paul Brown in the inner list. Then you need to do name -2, which is now the inner list. There you need to do remove and then Brown. And if you do print Brown, no, print name, then you will have now there is no Brown in the above. There is a Brown above here, Brown, but this one does not have a Brown. I think this is and reverse sort. We can do sort. If you do sort, then let's say reverse. Reverse is sort. Sort the list in the ascending order and return none. So sort doesn't return anything, but name itself will now sort. If we do sort and then print name, then it'll be here the issue is because this we have inner list, therefore it cannot be sorted, right? But if you want to sort only that inner list, that is possible. So we can practice that inner list only sorting. Oh no, not this. We need to sort inner list here, -2, and sort. Then previously we have inner list, we have Chris, Paul, Nathan. After this sorting, then we have Chris, Nathan, Paul. Okay? So when you do this sort, then the list here, the object, should be all in the same type. Right now, name itself not in the same type because all others atomic value, but one of those now is iterable, which is another list, inner list. That is the reason. So sort can be also practiced. So we did pretty much many here, right? In this list. So now, as you can see here, now we know these guys can be represented in a list. But if you want to represent not as a group, but any specific objects in detail, then you need to use a scriptor, right? So, for example, that is called the list. I mean tuple. Tuple is a data type that can hold multiple values, but those multiple values can constitute on objects. For example, here Adam, I want to declare a variable Adam. Adam can be, say, name Adam, and his major is cyber. We can do the first value in double quote, second value is a single quote. As far as they are paired, it'll be okay. And then GPA 3.7, let's say 3 of those. And if we want to print them, then, oops, here, then it'll be this. Difference between list and tuple is in the form of open parenthesis and close parenthesis, like here. Open and close parenthesis. Here square bracket, here open and close parenthesis. If it is a tuple, I want to bring one more here, basic. I want you to compare. Help, tuple. If you see a tuple has only these two methods, count and index, as opposed to the list. List has sort, reverse, remove, pop, insert, index, extend, count, copy, clear, append. So many methods available, but But here, tuple has only count and index. Very small number. But as you see here, this is very similar to the list. Even if you say Adam list and if you say here, this is a simple Adam tuple, the very same values can be represented in a list instead of a tuple. See, you see the difference here? For the representation tool point of view, there's no difference. Either you use tuple or use a list. Either you use round parenthesis or you simply use a square bracket. Square bracket, by definition, we see, oh, that is a list. Round parenthesis, by definition, we see simply, oh, that is a tuple. Representation point of view, as you see here, there's no restriction, no difference, no, nothing at all so far. Why then we need a tuple? Why not list? As you can see here, list has lots of methods available so that we can use. Methods, if it's a list, then lots of methods here. If it is a tuple, then only these two. Then why we distinguish tuple and list? Think about that. Think about that, okay? There's informal homework. You can ask to me next week. Hey, Professor, you said representation point of view, tuple and list are the same. Only the difference is the symbol. Tuple uses square bracket, and the list use square brackets. Tuple use round parentheses. And we know that list has lots of methods available. Tuple has only two. Why Python provide us very similar form, but in two different ways. But there is a reason. I want you to find that out. Probably no one tell you that much. Semantically, they are different. Semantically, as I said, this is a semantics, right? Tuple can be tuple can, if you describe as tuple, then each element that is a descriptor. So all together can constitute an object. Fine, right? This, if they are each one of them is an element in the given list, then they're all the same way. If we say name, then Paul, John, Smith, they are in the list. If we say GPA of those people, then 3.5, 3.3, 3.7, 3.9, 4.0, that is a list. So semantically, we know there is a difference. If it is a list, then simply all the elements in the list supposed to be in the same type. If it is GPAs, all GPAs. If it is names, all student names. As opposed to tuple, then all of those, each one of those will be, each element is a descriptor altogether. All the elements in a tuple together to constitute an object. So to describe, for example, an automobile, then we can say, let's say here, car 1. Then we can say Toyota and 4-cylinder and model is what is the model? Toyota. Toyota has I think Highlander, right? I'm not sure it is one word or two words. Toyota has Highlander and then 4-cylinder and mileage maybe 23 miles per hour. We can say 23 miles per hour mph. Then that is a car 1, right? Print car 1. So that is that one's. But if we say cars, the list, then we can say there is a car 1, Toyota car, and Ford car and General Motors, things like that, right? So we can do, that is a cars. There's a list. This is a list. This is a tuple. Same thing here. This is a list. This is a tuple. Now we'll look at dictionary. Dictionary is like a dictionary. So what is dictionary? Dictionary is collection of key value pairs. What is a dictionary, by the way? In your mind, what is a dictionary? Yeah, book of words and meanings. So given word, then dictionary will give it to you the meanings of that word. So the word is a key, and meaning or annotation, that is value, right? So that is the dictionary. Exactly same thing here. So dictionary can be is in the form of curly braces, open and close, and then you need to put here key colon value. But if it should be a collection, there could be many. So key 1, value 1, and delimiter comma, key 2, colon, val 2, and so on and so forth. That is a dictionary. So as an example, let's combine students' names and their descriptors. So we can say student. Student is a dictionary. Let's say name is, first name, it says Adam. And then name is Adam and GPA major. Major is 3 points. Major is cyber. GPA is 3.7. See here, this is we have Adam, cyber, and 3.7, right? That I described here. Here, when I say tuple, then although each one of these is a descriptor, but given a table, given a tuple, all the elements in a tuple can constitute together to an object. But here more clearly, we say what is an Adam? What is Adam is nothing but name. What is a cyber? Cyber is nothing but major. What is a 3.7? That is nothing but GPA. That's how I describe it here. And then if I say print name, print student, then I have here now student is name is Adam, major is cyber, and GPA is 3.7, right? So what about I do students, multiple of those? How can we make it? We can make, because it is a multiple, so I would say this guy is one case. In the list, I would say that is 1. And then second one is, I would say name is, what did we have name over there? And next one is Smith and Peter. So we say here Smith. Smith major is cyber, GPA 3.3. Same thing, comma, and then we can do more. Adam Smith and Peter. Peter major is computer science, GPA 3.5. Okay, and then we can say print students. Then we will have here a list of dictionary. So this is a dictionary. Dictionary called a student. This is list of dictionaries So you can simply, if you want to see this more clearly, I would say in this way. I think because of this, I have indentation. This is not going to work. Should be in one. Yeah. Because the Python is indentation a sensitive language. So anyway, like this. So for example, if you want to here in the dictionary, if you want to add new key and value pair, then there's two ways that you could do. You can do simply, before we do this, how can you access, by the way here, if it is a tuple, how can you access? Tuple can be accessed in a way similar to the list. So for example, Adam and 0, okay? So print first element in the tuple can be accessed by an index, very similar to the way that we do. Very similar to the way in, I want to, so the first element in the tuple can be accessed by index, so we used index 0, which is the first element. So Adam can be accessed. This is tuple, right? So Adam is tuple variable. This is the list variable. List variable Adam, list and 0, that still have Adam. So they are the same, the way that we access. Okay. What about manipulation? For example, how can we append? How can we extend? How can we modify this? Currently, 3 of these values together constitute an object Adam. Later, what if I want to add one more descriptor to describe about Adam? Is it possible? It's not possible because there's no method available. But so far, the way it is accessed, the way access tuple is the same as the way list is accessed, right? Somehow, if you can temporarily convert it to a list and do using some of the methods that's available for list, and we manipulate whatever we want to do, and finally, if you turn it back to a list, then there's a there's a way over that we can manipulate. Although tuple itself does not allow it, but anyway, we could do somehow, right? So the way that we could do is there's a conversion between tuple and list. Okay. So I would say I want to comment this out because we want to Adam list. Adam is a list, is a tuple, right? Adam, this is a tuple that can be converted to a list if we say list. List of tuple will return a list. I would say here, what is Adam? Adam is a tuple. If I say list Adam, then there is a list. See here difference? Adam is a tuple. Originally, it is defined as a tuple. So we have a curly, round parenthesis. As far as I'm using list and given tuple object, then it'll turn to a square bracket. Once it is turned to a square bracket, then I can remove, I can insert something, I can append, I can extend. That is possible, right? So the way that you could do is after you list, then you can assign it to Adam list. And then print Adam list. Then it'll be now Adam list is a value, is a list. So that you can do Adam list append, say GPA and number of credits. So 100 credit hours so far for undergraduates. And then if you do print, and therefore you have one more 100 in the list, but you can change it back to a tuple by call tuple, and it'll take Adam list, then it'll be a tuple of a list, and then you can say that is back to Adam. You can say back to Adam, and then print back to Adam. Then it'll be a list again. Adam list by having one more value, 100, then it is still a list. So if you want to convert back to a tuple, then you need to use tuple with the parameter list, then it'll be back to a tuple. So it'll be a tuple now. If it is a tuple, then you cannot do, for example, here, back to Adam append 1000. It is not possible. Adam, that is a tuple, so that you have extend ABC. That is not possible. Extend is not. Tuple does not. Here, tuple object has no attribute extend. Tuple attribute no attribute append. This is tuple. This is a dictionary. So dictionary. So before we add, we need to do access here. Dictionary value can be accessed by key. Tuple and index, tuple and list. Tuples and list, the elements can be accessed by index. But dictionary, there is no order. This is a collection, right? Tuple is a data type. So we can say unordered data type. List is a data type, ordered. What does that mean? We know this is the first one, this is the second one, this is the third one, this is the fourth one, right? And therefore, we can access each such elements by using index. Same thing, tuple. But dictionary, simply collection. It's unordered. Then how can we access it? If I want to access Adam, then how can we access it? We can access it by name, right? What is a name? So what's the name of students? Then we can do print student and name. Then we can say Adam. Adam comes here, right? Adam can be returned. So by key, that is the important. Add a new key and value pairs. How can we use it? The first way that we could do is using a key. Second one is using a method called update. So if you see here, dictionary, then dictionary has quite enough methods available. Clear, copy, get, items, keys. If you want to see items, then it gives me all the items. Item is the values. If you want to get all the keys, then it can give you key, pop items, set default and update values, d-dot values, and it gives you a list of these values and items. Items gives you pair key and values. So here, okay, some method invocation. You can do print students keys, You can get the keys. You can get the items. You can get values. Okay, so hit enter. Then you have here keys. It gives you a keys, name, major, GPA. See here, name, that is a key. Major, that is a key. GPA, that is a key. If you want to extract key, the list of keys only, then you can make this. If you say student.keys, then list of keys will be returned. Items, it gives you items in the form. If you see items, then see here, entire, that is a list. See here, square bracket. Each element in the list is a tuple. Therefore, it has a name and Adam in a tuple, major and cyber in a tuple, GPA and value 3.7 in a tuple. Okay, that is the item. Values, it gives you only values, Adam, cyber, and 3.7. So Adam, cyber, and 3.7. So given this dictionary, you can access keys only, values only, and key and value pair in a tuple as a whole in a list can be extracted, which is the method called items. So method can be invoked in this way, and values can be accessed in this way. Now, how can you add, or how can you add or replace? Okay. So, for example, if we want to do add one more key and value, say credit hours. Credit hours, and this is a key and value, say 101 credit hours. Then you can do print, you can do student, and key is credit hours. And you can say 101 and print student, then you see that is added. Type that. I want to put here double so that we do it later. See here, credit hours 101, that is added, right? New one is added. Or simply, you can do also replace GPA to 3.78. Then you can do student GPA and then 3.78. And if you want to see student, you may be able to see the replacement updates. See here, GPA is now 3.78. Previously 3.7, but now 3.78. This is a replacement, right? Update, so-called. Or you can do you can simply add. If there is a key already exists, then that will be replaced. If there is a new key, so far we have only the key, name, major, GPA. If there is a brand new key, then new key is added. That is the addition. The other way you could do is update. Okay, you can do update, say update GPA to 3.99. Then you can do student dot update, and then you put here, you need to see here very carefully what is update. Update, here is a updated D from the dictionary iterable, E and F. E represent the key and value pairs. So update, then you need to put here GPA, let's see, what is it? Update, only update. I want to see before we do here, tuple dictionary. Oh yeah, update not in this square break. It should be dictionary form like this, because it is a dictionary update, so it should be dictionary form, not a list form. So GPA is 3.99, right? GPA becomes 3.99. In this way, using update, we can update or replace. In the same way, this is update. Similarly, if you want to add, for example, not credit hours, but let's say salary, pay is $10,000. Then same thing, student.update, within parentheses, make sure that is a dictionary form, and then you can say pay. In the dictionary, you can say 10,000. Then print student. Then it'll be here, pay is 10,000. I know this is a tough so far, because so much languages you should learn, but you have to do practice. I'll give you homework assignments so that you can practice it. If I ask you to please practice it, then probably you guys do not practice. Same thing to me. Why should I practice if there's no obligation? So that is the reason I give you homework assignments. So today we learned list, tuple, and dictionary. They can be combined. List and tuple converted. Dictionary, so that you can include some others as well. One of those I'm going to use here. See here, this is a list as a whole. List, as I said, this is a list of dictionaries. So how many dictionaries that we have? Here there's a dictionary, and another dictionary, and another dictionary here, right? So how can you see here? Another way that we could express this is students number 2. We can do it this way. Adam has a dictionary. I want to copy this. This is a dictionary of dictionaries. So access can be differently. If we want to access, for example, Adam's GPA from student, then you need to do students. Adam is in the first element there. And then you need to do here GPA. Or if we use print student 2, student 2 is, there's Adam. Adam can be accessed by Adam. Key. It returns another dictionary. So if we put here GPA, then it'll be returned. Look at this. I want you to think of two cases here. Students, that is a list of dictionary. So if you look at this upper top level, then that is nothing but a list. Therefore, first element is first list. Second element is a second list. Third element is a third list. So if we want to get access to the Adam's GPA, then we know Adam is in the first element in a list. Therefore, we put here first element. Then think of this. This itself returns, if we sit here, then this guy returns list, right? From here, there is a list. If it is a list, then you can access a particular value by using a key. So that we use key in the square bracket, right? Can be accessed by a key here, right? If we want to get a student name, then we need to use a key. Key can be used to access a value. So we use that. For the case of this students, which is a list of dictionaries. Similarly, we defined students 2, number 2, which is a little different. That is a dictionary of dictionaries. See here the notation. Unlikely here square bracket at the outer level, but here only curly braces, outer curly braces. So you can access this value, whatever this dictionary, by the key Adam. This dictionary can be accessed by the key Smith. This dictionary can be accessed by key Peter. As far as we know Adam's GPA, then we know this is the key Adam. So we need to put Adam. So this, if we say this here, then this will return the same thing. Values to this key is a dictionary in this case. The first case, element to this index is a dictionary. And after that, there is a value access in the dictionary by using a key, GPA. Okay.